In today's project, we will continue yesterday's project and complete our piano by adding pitch. Today's project builds on top of yesterday's project. In yesterday's project, we could only play 7 notes, but today we are going to be able to play all different notes in the entire spectrum by using a potentiometer. That way we can expand on these notes. So right now it sounds like this. And now I'll adjust this potentiometer. And now this is what it sounds like. Now let's get into the materials. For this project, you will need 1 Arduino Uno, 1 potentiometer, many jumper wires, so you can see around here. These little connector wires, you can use jumper wires, but these are better for this use. 7 push buttons, preferably of this type. These are the best types of push buttons, and you can find the links to those in the description. And we will need 8 resistors. The first one does not matter the resistance of, something relatively small. And then the other ones have to be all different, and this one has to be in ascending order. And we will also need 1 speaker, and that's it. The code for this is just an addition to the prior video, in which we explained the basic version of this type of piano. Now, initially we will set up a variable called S. This will allow us to figure out the resistance that we're getting versus the 5-volt power supply we have. Next is our pitch variable, our speaker variable for the speaker pin, our sounds. These are all sounds in the first octave. That way they can be increased on our potentiometer. And now we have our LED pin. This is just our inside LED, the built-in LED. And we have our resistance array that contains all of the different resistances that will be populated. And we have our beat time. This allows us to have a length of the beat of our tone, or our sounds. Now, in the setup function, we are doing 3 pin mode initializations. We're setting up pin mode for pin 0, which is the pins for the buttons, pin mode for the analog 1 reading, so we can measure from the potentiometer, and finally our pin mode for our built-in LED. And now here's where we automate everything. So we are doing digital write for our LED and setting it to high. So it'll be high and light until we finish this. So until we have initialized all the buttons. Now we will, right here, what we're doing is checking if the current resistance is 0, and if it's if at one point this is not 0, when someone presses the button, then we can continue on to the next while loop, and then we can check while it's not 0. So we're basically waiting for the person to release the button, and then after that, if this is the last button, then we just turn off the LED so we know that we finished. Now in the loop, we're just reading, doing an analog read of the resistance to figure out which button we're pressing. Now, for the pitch, this is a little bit more complicated. We're using a function called map. You can think of this as proportions if you've ever learned those. Basically what we're doing is we're taking the value of this potentiometer, which is of any value in this range, up to 1023, and we're converting it into a range from 1 to 8. So if it's in, let's say, an easier example of this might be converting something from the range of 1 to 40 to 1 to 4. So I can write that down. So we're converting from 1 out of 40 to 1 out of 4. And you can think anything up to, well, anything less than 10 or up to 10 would be converted to a 1. Anything in like the range of 20 to 29 or so might be a 2. And that's how that would work. Now, we just do a default to turn off whatever is going on with this so we can start fresh. And now we go through this whole system where we will check which button's being pressed, and we make a tone on the speaker. And the beat time is necessary, otherwise the beat will just continuously play even after we've stopped pressing the button, and then we just wait the length of the beat. If you want to support the channel or you just like watching the videos, then make sure to subscribe. It helps me out, and it's easy as clicking a button.